Welcome to what's probably going to be a two-part video. I had an idea of just making a quick little project in Golang that was just going to be something kind of fun that I could upload. I've been learning Golang as kind of a way of moving into a new career path, and so to do that, I am just building some projects, and here's one of them. So this will all be available on GitHub. I'll post the links below. I'll do all the cool stuff. You can follow me on those links. And yeah, so here is what we're going to do. We're just going to take an image. I have two images here. I have a lion, I have a bike. And we're just going to pixelate them. And then we're going to, in the second video, we're going to what's called quantize them, which is just to take a set number of colors and limit the pixels to be one of those colors. So let's just jump right into it. What we're going to do is we're going to start off with a few variables. We're going to start off with an input path. And the input path here is just going to be our lion.jpg. Great. And then our output path is going to be equal to something like lion pixelate.jpg. Then we're going to do a pixel size, right? And the pixel size is going to be something like 10. Now, it's not going to be like 10 pixels by 10 pixels. What it's going to be is every pixel that we have in the image is going to basically be blown up to 10 pixels. And so the way we do that is we're going to loop over a bunch of pixels in our image, and we're going to take one and then fill in the pixels surrounding it with that pixel. So we're going to sample one of the pixels and then basically fill in the chunk around it. And so what we can do here is we can take an input file, and error is going to be equal to os open input file, input path. Okay, and that should input our OS package. If error is equal to nil, we're going to log.fatalf error opening image error. Okay, so just a little bit of error logging, and then when we open an image, we need to actually close it too. So input file.close as well, and then we'll go ahead and do our output file as well. So output file error os open output output path, and then we'll do the same thing. If error is not equal to nil, we're going to log fatalf error creating image, and then we'll give it the error. Defer output file dot close. All right, great. And so within here, what we're going to do is we're going to decode it first, decode the image, and then we will pixelate it. Okay, and then yeah. So we'll start here. We'll create our pixelate method. First, let's decode. Yeah, let's decode first. So what we can do is we can take an image and then our format, which we're just going to stick with JPEG for now. But if you wanted to do like PNG or whatever, you could save it as that as well. So, and then error is going to be equal to what do we got? Our image class decode input file, correct? I believe. If error is not equal to nil, we will then log fatal f again. Error decoding image. The error, perfect. And then yeah, and then so here we can start by, then from here we can pixelate. So let's go ahead and write a pixelate function, and what we're going to need is an image, and that's going to be type image, and we'll also need a pixel size, which is going to be just an int. And then we're going to return the image dot image. So we're going to return an image basically, right? Okay, so first thing that we're going to do is we're going to get the size of the image, okay? So we got our bounds, and we can get that by just doing bounds. Super nice and easy. We'll get the width, which is going to be bounds.max.x, and then we're going to get the height, which is going to be bounds.max.w, or y, not w, y. Then we got our results, and that's going to be a new image of new RGBA within or of size bounds. And then we'll return results at the end. All right, So now we got to do our actual pixelation. And so like I said before, what we're going to actually be doing, let's move this back a little bit. So what we're actually going to be doing is we're going to loop over our image, the pixels of our image. But instead of looking at every single pixel, we're going to be looking at basically every pixel sized worth pixel. And so we'll take pixel number 1 and then we'll skip 10 pixels. In this case, we just have 10 as our pixel size. So we'll skip 10 pixels and then we'll do another pixel and then we'll do another 10, skip another 10 pixels, do another pixel. And that's going to be our sample pixel. Then what we're going to do is we're going to take that sample and we're going to distribute it to the pixels surrounding it. So first we're going to do a for loop of starting with 0, and then we'll do y is less than the height, y plus plus, I'm sorry, not plus plus, y plus equals pixel size. Okay, so we're skipping pixels. X is going to be equal to, starting at 0, x is less than w for width, x is we're going to loop over pixel size as well. So then we're going to take our sample, okay? And our sample is going to be image at x and y. We're going to take that pixel and we're going to distribute it to the rest of them. So now we need to do another double for loop. So we can do dy is going to be equal to 0. Dy is less than pixel size, and dy is, and y plus dy is within the height of our image, dy plus plus. For x, dx is going to be 0 again. Dx is less than pixel size, and x plus dx is going to be less than w, and dx plus plus. Now, what we're going to do is our result, we're going to set at, so remember, we're taking a sample pixel and then we're basically distributing it to the pixels surrounding it. So x plus dx, y plus dy, and our sample pixel. And then we'll return it. That is our pixelate method. Let's see how it works. So we can take this and go pixelated image is going to be equal to pixelate, and we'll send it our image. We'll also send our pixel size, and great. Now before we actually run this, we're going to have to encode it. We're going to re-encode it. So what we can do is error is going to be equal to JPEG dot encode. Yeah, there we go. JPEG encode output file pixelated image, and then because we're doing JPEG, we're going to do JPG options. Quality is going to be equal to 100. Great. And then after that, we can do if error is not nil. We can do log fatal f error encoding output image, and we'll get error. And then finally, we can just do log printf pixelated image saved to output path. All right, what do we got here? What's going on here? No new. Okay, yeah, I guess error already exists in several places. So great. That we can go ahead and run it by going go run main.go, and it's going to pixelate it. Okay, wait, we have an error. Error creating image. So that's where we come down here. Error creating image. Open lion pixelate.jpg. No such file or directory. Oh, our output file needs to create the image, not open it. Okay, so let's rerun it again. There we go. Pixelated image saved to here. So here's our original image, and then here's our pixelated image. So you can kind of see it. Let's bump up the values quite a bit so that you can see it. So let's do like 40 or something. So remember, instead of making it 40 pixels, it's actually taking a pixel and basically taking a sample pixel and blowing it up to 40 pixels. There we go. Looks a little bit better. Let's do 100. Let's go all the way up. Make it crazy. Bam, there's our big pixelated image. All right, so that is our first part, which is just pixelating the images. Please follow along for part number 2, where we quantize the image, meaning we're going to take these pixels and average them down, and then we're going to average them down, and then we are going to make it like 4 color, 8 color. We can make it 2 color if we want. So if you like this, like, subscribe, follow along. I would like to post a lot more videos like this. So if you liked it, please give me a, what on earth was that? Did that work? See you next time.